In this word problem, we are given that a description that comes out to look like this. And we're told that theta equals 20. And we need to find, both those red dots are Saurus, the planet. We need to find the closest distance to the class M, which is the blue planet. Closest and furthest distance. So to solve this, there's two triangles, two possible solutions. The shortest distance, which is this guy, and this is the triangle that we would solve to get that short distance. And then the longer distance, which is this guy, and then we would solve this triangle to get that distance. Okay, so solving that green triangle first. So this is, both of these give us an SSA triangle, right? We have the 51 and the 82 are adjacent sides, and then that angle is 20. So we have, and that 20 is given to us in text, not in the picture. So we just got to solve those two triangles. So the first one, let's see, let's use law of sines. So sine of, well, let's give these angles some names. So in the green triangle, well, let's call this guy alpha and this guy beta. So then the sine of 20 is opposite that 51. And let's see, we have alpha, so sine of alpha is opposite the 82. And sine of beta is, well, that is the question, right? That's the shortest distance between Saurus and the class M planet, between the red and blue dot. So that's kind of the first thing we need to find. So let's just call that X. All right. So we can solve for alpha, but we can't solve for X yet because we don't have beta. But actually, in the law of sines, sine's always going to give us an angle that's smaller than 90 degrees. So that alpha is actually the complement of this one. So in our triangle, that alpha, the green triangle, that alpha is across from 82, and in the purple triangle, that alpha is across from 82. So the sine of alpha is paired with that 82, but this is the one that sine inverse is going to give us, the little one. And the obtuse one is going to be 180 degrees minus that, or the supplement of that. So I can go 180 minus alpha there. Okay, so really, we're solving for the purple triangle first. So I'm going to go ahead and just write this in purple. So sine of alpha over 82 gives us the purple triangle. Okay, so let's solve for alpha. Then we can just cross multiply, and we get 82 times sine of 20 equals 51 times the sine of alpha. So solving for sine of alpha, we get 82 times the sine of 20 over 51. And taking the sine inverse of both sides. So that I'm in sine inverse of that bad guy. And on the right, it just simplifies to just alpha. So we get alpha equals, actually it's approximately equal to, not equal to, since we're going to use a calculator to estimate that. So we get sine inverse of, so sine inverse, I'm in degrees. Yeah, my 20 is in degrees, so I'm in degrees. And I have second sine inverse of, do a parenthesis for my numerator, which is 82 times sine of 20. Close the sine, close the numerator, divide by 51, and then close the sine inverse parenthesis, and that gives me an angle of 33, let's round that up to 33.4 degrees. So that purple triangle has alpha equal to 33.4 degrees. That means the green triangle is going to be the supplement of that, so 180 minus that. I'll leave that in the calculator so I get an exact number. Why is it giving me multiplication? So then that gives me the other possible, the green triangle is going to have alpha be 146 degrees. So the green triangle has alpha approximately 146.6 degrees. So two possibilities for alpha. The green one gives us the shortest distance, the purple one gives us the long distance. And let's see, what are we looking for now? Okay, now we need to solve for x. So x is, in the green triangle, it's this little short distance between alpha, the blue and the red planets. And in the purple triangle, the other option with alpha equal 33.4, it's this distance. This thing is x. So let's do the purple one first. So I now have alpha is 33.4 degrees, so sine of that, and its pair is the 82, equals sine of beta. Oh, right, I need to get beta first. So for beta, let's back up a little then. If alpha is 33.4, then that means beta would be 180 minus alpha and minus theta. So that's 180 minus 33.4 and minus 20, which gives me that beta is 126.6 degrees. And if that's true, now I can get x. So now I have my sine, law of sines, my sine of alpha is 33.4. And across from that, I have the 82. And now sine of beta is sine of 126.6 over, across from beta, we have the big X, the big purple X. So I'm doing this part of the law of sines right now. Okay, and then I can solve for X as, by cross multiplying, I get 82 times sine of 126.6. And then after I cross multiply, if I divide by sine of 33.4, then I will get x by itself. So let's grab our calculator. So let's see, I got 82 times sine of 126.6, close that sign, and then divide by sine of 33.4 and close that sign. And I get that x is approximately 119, let's round that up to 119.6. And this is million miles. So that's our answer for the furthest distance that those two planets could be apart. And to get the closest distance, that other x, so let's call this x, I don't know, x2 because it's bigger, and call the green one x1. Call this guy x1. So to solve for x1, I do the same process, but this time I'm using alpha equal to 146.6. I shouldn't even say alpha, I should say it was actually 180 minus alpha. So it's the other little angle over here, on the red planet. Okay, so if this guy across from the 82 is 146.6, then I get sine of 146.6 over 82 equals sine of beta, which, oops, I gotta find beta, don't I? Beta equals 180 minus those other two angles. So this time it's going to be minus 146.6 and minus 20. Which gives me 13.4, just a tiny little angle. So sine of beta is sine of 13.4, and across from beta we have our distance in question, that short distance, and we get cross multiply, get x1 equal, cross multiply, I get x1 times the sine of 146.6 equals 82 times the sine of 13.4. And to get the x by itself, I'll divide both sides by sine of 146.6, and I get x1 equals 82 times sine of 13.4 divided by sine of 146.6. Okay, calculator time. So I have, in the numerator, I have 82 times the sine of 13.4, close that sign, divided by the sine of 146.6, and close that sign. And we get the shorter distance, which is x equal to 34.5, and it's still in the same units. So that's million miles. So there's the other solution. So together I have the longest and the shortest distances between those two planets.